Hello again. In this video, we're going to look at a couple specific forces relating to Newton's laws of motion. We know force, as far as the formula, is mass times acceleration. Now we're going to look at a couple specific forces and applications of those forces. For instance, gravitational force. Gravitational force is a fancy way of saying weight. Every object has a weight. But the book uses just lowercase w. I like to use f sub w to remind you that it is indeed a force. But force of weight is equal to mass times gravity. In other words, we're taking Newton's second law of mass times acceleration, just putting a specific acceleration to it. That being the acceleration due to gravity, which we've already learned about. And of course, that unit will be Newton's as well. So if I ask you to find a weight of an object, let's do an example, that had a mass of 20 kilograms. And I want to know what that object's weight is in newtons. Very simply put, force of weight is just mass times gravity. So you take the 20 kilogram mass times gravity. Today I'm going to round it to a negative 10 meters per second squared. You end up with a negative 200 newtons. Now in this case, the magnitude would be the 200 newtons. And the direction would be the negative sign, which is denoting downward. Weight is always negative because it's always in a downward direction towards the center of the Earth or whatever planet you happen to be on. So that's one specific force I wanted to discuss, that being gravitational force. Next one is net force. Now when we talked about Newton's second law of motion and force equals mass times acceleration, that is technically the net force. Now net force, think of your net pay. You have a gross pay starting off, you have all these deductions for taxes, healthcare, all that. You end up with a net pay. Forces act the same way. It's your applied forces minus any frictional or resistive forces. In other words, if I'm pulling this table with 10 newtons of force, I'm experiencing 2 newtons of friction against me, then that's 8 newtons overall net force in my direction, or the direction of my pull. But even if, say, I'm pulling this table with 10 newtons, someone else is pulling with 5 newtons, and there's still 2 newtons of friction. So basically, if we add that up, if you have 10 newtons in my direction, you have 5 newtons opposing me and another 2 newtons of friction. What you have to do is you just have to consider the forces in the directions. You have 10 newtons to the right, a total of 7 newtons to the, 10 newtons to the left rather, a total of 7 newtons to the right. 10 minus 7 would give you an overall net force of 3 newtons to the left. So you're really just summarizing the forces in all the directions. And that's really what net force deals with. Lastly, we have normal force. Normal force is typically a stationary object that just resists the weight of another object. In other words, right now, my weight is pulling me downward. But why aren't I falling? I'm not falling because I have the floor underneath my feet. The floor is acting as a normal force pushing back up on me, resisting the force of my weight. For you, if you're sitting in your chair, it would be the seat of your chair, because your weight is centered on your posterior right now, which is on your chair, and therefore the weight pushing back up, the normal force pushing back up, would be the seat of your chair itself. If you think of, say for instance, when you're in class and there's a book sitting on the table, the downward force would be the weight pulling down on the book itself. The normal force would be the table pushing back up on, or tabletop I should say, pushing back up on the book. So these are just a couple specific forces you're going to run into in Chapter 4, and I just wanted to give you a very brief overview of how each of those work.